In this video, we're going to talk about the distribution of data and what it means. So a distribution shows all the possible, we're going to put observed or theoretical outcomes of data. So theoretical outcomes of the data and their frequency. And so if you remember, we've represented data through histograms and through box plots. And so if we're looking at data through a histogram, you can see where it could be skewed, where there's a tail to the left. So what that means is that the lower numbers are going to drag the mean, the average, down. And so we call that something that is negatively skewed, which makes sense. The lower numbers, okay, are bringing it down. If it is fairly symmetrical, okay, that means that the mean is the best way to represent the data. There is no skewing happening. And then finally, we could have sort of like a tail to the right, where the positive numbers are going to bring the mean up. So that means it is positively skewed. And similarly, you're going to see that in a box and whisker plot. So here in this box and whisker, you can kind of see a longer tail on the left. Therefore, it is negatively skewed. Here, I would say both whiskers per se are the same length, therefore symmetrical, and there is no skewing happening. And then in the final one over here, you've got a longer whisker to the right. So your positive numbers are going to pull on the mean, making it a positively skewed data set. So let's kind of build our own here. So what I want you guys to do is pause the video, and I want you to throw these numbers that you have here below onto Stapplet. And I want you to go ahead and sketch a histogram as well as a box and whisker plot. And we're going to just kind of observe what's happening. So hopefully you've sketched something like this. If not, at this point, pause the video, make sure you're doing so. So in my histogram, I can kind of see here that it's going up and then down. I would say that there is more of a negatively skewed data, and you can also see that happening in my box plot, where this whisker here is longer than over here. It was pulling on my mean. And so when I'm describing the shape of these two, I would say I find more data to the right. So find data to the right, more of it, with a few to the left. So we would say negatively skewed, which kind of answers the next question. What does this shape mean? Okay, it means that we have lower numbers that are skewing the data and the average. That's where the name comes from. Negatively skewed, positively skewed. Okay, and so with this being said, that helps us to analyze our distributions and determine, well, what is the best measure of center or measure of spread? So let's kind of recall what is measure of center. Maybe it's been a while. So measure of center, remember, is your mean, median, or your mode. Oops. And your measure of spread is more of your range, your outliers, quartiles, and let's see, your standard deviation, your interquartile range. So your 5-number summary is essentially what I'm reviewing here. So if we have symmetric data, okay, symmetric meaning there's no skew left or right, we are going to use the mean to represent our data. Okay, that and our standard deviation. Now, if it is skewed, the best way to identify or represent our data would be best to use your 5-number summary. 5-number summary. So that measure of spread. And the median. Because remember, if it's being skewed, the mean is no longer very accurate. it's being pulled down from negative or positive numbers. So let's look at a few examples below. So it says, describe the type of distribution, determine the appropriate measure of center and spread, and then explain the relationship between the mean and the median. So in example A, we've got a histogram that's showing the age of the Best Actress Award from 1928 to 2009. So if I'm just analyzing the graph in general, most actresses were between the ages of 30 and 36, but we do have a few outliers. So if I were to kind of outline this data, I would say it is being positively skewed, right? So I'm going to write that down. So positively skewed. Therefore, it's not symmetrical, right? And according to my last slide, if it's not symmetric, I want to use my five number summary. So I'm going to put 5-number summary will be best, along with using the median, because my mean in this case would be skewed to the right, skewed positively. In example B, let's see what we have here. We must have been measuring people and their height in centimeters and how often we measured said height. So if you look at this one, this is pretty symmetrical. I could like cut this right in half and it would almost like fold on top of itself. I don't see any skewing happening. So I'm going to say that this is symmetrical. And that means I'm going to use my mean and standard deviation to summarize this data, okay? My mean is not being skewed in any way to the left or right, and that standard deviation tells me the range of which my heights were recorded. Where was it pretty close to the mean? Was it pretty far away? Okay? So in this last one, what I'd like you guys to do is hop on to Stapplet, and I want you to enter in this data below on the money that was donated. I want you to sketch either a histogram or a box plot, and then tell me what would you use. Is it because based off of it being positively skewed or negative, would you use the mean or the median, 5-number summary, standard deviation, and so forth? So here I used box plot. You could have used a histogram, which is fine. But what I like about the box plot immediately is that I see an outlier, right? So immediately I know it's skewed. So I would say this is being positively skewed because of my outlier being all the way up at 100. It's going to pull at my mean. And if you even look down below, I pulled this off of Stapplet. My mean is 37, right? But my median is 33. Look at how that mean is being positively skewed. Okay, it's increasing. So the best appropriate way to represent my data would be my 5-number summary, which is why I have my box and whisker plot here with my median being 33.